Welcome to the next lecture of this course, property table. In the last lecture, we saw about different phases of pure substance. Then we saw PV diagram, then we saw PT diagram, then we saw VT diagram, then we saw PVT diagram. Then we understood what is the need for PV diagram, and then we moved on to defining specific volume. We went into enthalpy, and then we also saw about supercritical fluids. So, these were the topics which we covered in the last lecture. In this lecture, we will try to cover a most important topic or a very important topic, which is psychometric charts or psychometric tables. So, we will see that. So, that is very important. This is very much useful while designing a system for the requirements. So, these are the topics which we will cover in this lecture. All these topics are very important because you will have to understand each one of them, and then while giving a problem in the examination, you have to extract it from the table and then solve the problem. However, in the examination, we will extract the values from the table and give it to you because it is an objective type, but in real time you will have to go through the chart. Thermodynamic property table. It is an indispensable tool used by engineers and scientists to determine the physical and the thermodynamic property of pure substances, especially when analytical expressions are not available or practical. These tables, the property tables, these tables provide experimental or computational data that reveal various properties such as pressure, temperature, specific volume, enthalpy, internal energy and entropy of a substance under various conditions or different conditions. So, what is this property table going to give? This is going to give me a relationship between P, T, specific volume, enthalpy, H, internal energy U and entropy S. So, there is a relationship between all of them. This relationship, if you can plot it in a 2D, it is between two variables. If you plot it in a 3D, you get much more informations. And it is also going to tell me under various conditions, not only at pressure at 1 atmosphere, it can talk about 10 atmosphere, it can talk about 0.1 atmosphere, temperatures 100 degrees Celsius, 0 degrees, minus 273 degrees Celsius, all these things it can talk. They are extensively used in analyzing energy systems involving phase change. Example, in boilers, boiler what we do is from liquid to steam, condenser from steam to liquid, turbine where the pressure and temperature is lost, compressor where the pressure is increased, temperature can increase or maintained, refrigeration where it can suck out the hot air and blow in cold air. So, in all these things, these property tables will be used, where accurate data of fluid properties is essential for heat and work calculation. Finally, friends, we will have to find out what is the heat you apply, what is the work done you do. This is what you have been seeing in heat pumps and heat engines. So, apply heat, extract work, or apply work, extract heat, right. For this calculation, you need to have all these parameters P, T, specific volume, enthalpy, internal energy, entropy, all these values are required, so that we can try to find out the efficiency of a system. The most commonly used property table are saturated properties table. The lists properties of saturated liquid suffix F and saturated vapor suffix G at specific temperature or pressure. Useful when a substance coexists in two phase. When you are talking to a fluid expert or to a thermal expert, he says single phase, two phase flow and three phase flow. if you try to look at examples, single phase means it is one fluid. It can be fully solid, it can be fully liquid, it can be fully gas, single phase, right. When you have two phases, water and air, so steam and liquid, whatever it is, so that is called as two phase. When we talk about three phase, it will be air, water and one more substance, or it can be three different fluids, or it can be three different states of a single thing. So, these things are called as three phase. Single phase is very easy to solve the problem. Generally, we convert three phase into two phase or two phase into single phase and try to solve the problem to understand the system. So, useful when substances exist in two phase, when it comes out of a boiler, liquid plus steam, liquid plus vapor, which includes temperature, P saturation, V saturated fluid, V saturated vapor, then HF is enthalpy, which is liquid, this is enthalpy in vapor, S is entropy for a liquid, entropy for a gas, which also includes terms like HF can be written as G minus F, VFG can be written as G minus VF, SFG can be written as SG minus SF. So, this are the useful properties which you can extract from the table. So, if you look at a typical table, it is like this. And friends, today there are so many softwares wherein which you can try to just give some of the properties and get the further responses, whatever it is. So, if you look at it, water at 45 degrees Celsius, we will just discuss one point. Water at 45 degrees Celsius, saturation pressure will be around about 9.59 kPa. The liquid saturation will be at around about 0.0010. Then the saturation of vapor will be at 15.25 meter cube per kg. For this units is given here, specific volume. So, then internal energy you will try to have is 188.43, then the vapor will be 2247.7 and saturated vapor can be this. So, all this internal energy will be represented as kilojoule per kg. Units are very important because while solving the problem, you might have to convert 10 to the power 3, 10 to the power minus 3. In the examination, there can be objective question where we can have something like this answer 1.0, 0.01 or it can be 100 or it can be 0.001. So, if you see the answer somewhere it is 1 into 10 to the power minus whatever it is. So, you have to know the conversions properly, please keep that in mind, and there can be a factor multiplied by 10 while doing the unit conversion, please take care of that. Then enthalpy will be kilojoule per kg. So, internal energy is kilojoule per kg, enthalpy is also kilojoule per kg, keep that in mind, units are the same, right. So, here you will have 188.43, right, and then it is 2247, it is approximately the same. It is 2582, it is 2431, approximately the same with some approximation, right. So, it is very close by. So, enthalpy and internal energy values are very close by. When we talk about entropy, you will see that you will have 0.063, 7.5 and 8.1 for saturated liquid SF, saturated vapor SFG and then saturated vapor SG, you will have these values. So, here if you see the intermediate form is the two phase flow. When in the problem examination we give a two phase flow, you are supposed to take this value. But friends, this table will be converted into a unit and we will give you the units directly for you to solve. We can give you more values, but you might ask you, for example, I will give you for a water, all these things are there, all these values I will give you in a table form and ask you to extract exactly what is required for you to solve that problem and then you can solve. Next property is superheated vapor table. So, the property, first what did we see is saturated property, we saw saturated properties table we saw. Next is superheated vapor tables. It provides properties of vapor at temperatures above the saturated temperature for a given pressure. They are often referred to as a steam table. Like periodic table, you have a steam table. So, look at it. Provides properties of vapor at temperatures above the saturation temperature for a given pressure. Used when steam or other vapor behaves like gas. So, they typically have entries like T, P, V, U, H and S. The same thing, temperature, pressure, we have specific volume, internal energy, enthalpy and entropy. So, the supersaturated vapor table is this compressed, that is compressed liquid table, which is otherwise called a subcooled liquid table, which provides the data for liquid below the saturation temperature at a given pressure. Above the saturation temperature is superheated vapor table. Below the saturation table is compressed liquid table, below the saturation, superheated and subcooled. So, often approximated by using saturated liquid values at the same temperature when the data is scarce. So, when the data is not available for a particular fluid, so then you can use this. So, the same table is given here very clearly. So, then it is compressed liquid approximation. What is compressed liquid approximation? Compressed liquid approximation is below the saturation temperature at a given pressure. So, this was above the saturation temperature. So, the values are given where saturation of temperature is given, then V, U, H, S, then here we have when pressures are constant, P equal to 5 MPa, P equal to 10 MPa, P equal to 15 MPa. You can see how the values change for a liquid. So, it is given. So, this is given for water. You can, this is given only for 5, 10 and 15. So, when you are trying to develop a system and then you are trying to see with the pressure what is the values, you can try to get it from this table. So, H subcooled is approximated to HF at the rate of T unsubcooled, which is approximated to U F at the rate T, which is V subcooled, which is equal to V F at the rate of T. So, this is approximation which is used. This is accurate at low pressures and small temperature difference from saturation. We hold this equation. H cool, H subcooled, what is it? Enthalpy. So, F at the rate of T, it is under subcooled. So, it is U internal energy subcooled, then it is V subcooled and vapor we form. How to use a property table? This we have seen the table now, but now we will see how to use the table. Step 1 is identify known state variables. Friends, you would have gone through what is a state variable. So, identify known state variables. Depending on the problem, start with known variables such as pressure and temperature. Why are we saying known temperature variables, pressure and temperature? Because these two are easy to measure. Enthalpy, entropy, these are all difficult to measure. So, pressure and temperature are straightforward. You put a gauge, you measure it. So, depending on the problem, start with the known variables such as pressure and temperature. Determine whether the fluid is subcooled or saturated mixture or superheated vapor. You see, subcooled liquid, saturated mixture and superheated vapor. So, this we saw here, superheated vapor, subcooled liquid table and saturated mixture. We said the first table. So, now the step 2 is going to be use the appropriate table. If T and P corresponds to saturation, use saturated property table. If T is greater than T saturation for a given P, then use superheated vapor table. If T saturated is more than T for a given P, then use compressed liquid table. So, these are the 3 things which you should remember. If T and P corresponds to saturation, saturation means what? Up to the brim. Now, you can have at the top, at the bottom, up to the brim. So, you use saturated property table. Superheated, go up. So, then you use a superheated vapor table where T is greater than T saturation. When T is less than T saturation, then go for compressed liquid table. So, then what have you done? First you have identified the states, then you have determine the fluid whatever is there. Then you have taken the appropriate table. From the table you have extracted data. So, interpolate if necessary. See, if you have a y axis and an x axis and you have points like this, okay. So, you try to have a straight line, something like this, and now you have an equation for this line. Now, if you want to find out intermediate points, so that is called as interpolation. For example, y equal to 5x plus 3, you have found out some equation. Now, what you will do is, you will try to substitute at various x and try to get the values of y. So, that is called as interpolation. The other extreme end is, I have data points wherein which I have outside the line. Now, if I wanted to do an interpolation, or if I wanted to talk about this, it is called as extrapolation, which is out of this data points. My equation is valuable only to the, or valid only to the points which I have considered. This is called as interpolation, intermediate points where equation is done. Extrapolation generally we try to avoid. Interpolate if necessary. Tables provide discrete data points. If I want to make it continuous, then what I do is, I do linear interpolation. Friends, you might have exponential data points or equation. What we do is, we convert this exponential into a linear form, so that we can try to do the interpolation easy. There will be approximations, right. So, if values are needed between two entities, because in table what you get is discrete value. So, discrete value are here. So, now I want to get small values in between. So, if values are needed between two known entities, use linear interpolation. In linear interpolation, we write it as y equal to y1. So, we are taking 2 points y and x, 2 points. So, this is x1 y1, this is x2 y2, right. Y is a point which you are trying to get in between, where it is y1 plus y2 minus y1 divided by x2 minus x1 into x. So, for this point you will also have x minus x1. So, finally, what you get is a point called y. So, now from y you can try to find out x also. So, where y1, y2 are known property values, x1, x2 are the table entries, x1, x2 are table entry data, and y1, y2 are the property values which are known property values which are done. Tables, x in the input value and y is the interpolated property. So, it is very clearly now you see now y1, y2 are properties known. So, that is with respect to P and T, and x1, x2 are taken from tables, right. So, now you try to find out x and y. Third step. So, with these 3 steps, you try to figure out the values and try to solve, and thank you very much.